This video I'm going to build some sand batteries that have a couple gutters running through them to see if I can help heat my home using solar power. So the first thing I will do is cut open and pour out two 60-pound bags of sand into the first drum so that the gutters are not sitting on the bottom. And the next thing I will do is join 90-degree elbows together and wrap them with foil tape to help prevent sand from getting in them over time. One end of the gutter is crimped so it will fit inside the other, and I need to keep track of these as I put these together so they go with the airflow. Now I will smooth the sand out at the bottom of the drum and then place the elbows down on top of the sand so I can get a measurement of where I want to cut the next sections of gutter. I decide to try the first piece at exactly 2 feet or 24 inches, so I will use my combination square to make cut lines all the way around the gutter so I know where I'm cutting at. Next I will take a grinder with a cut-off wheel and cut on the lines I just made, and then join the 2-foot straight piece to one of the elbows at the bottom, but I have a little trouble getting them to go together. And after crimping and laying them on the side, I get the straight piece joined with the elbow and put it back down into the drum so I can see how well my first measurement will work. I will put another elbow down next to the straight pipe where I want it to be outside of the drum and measure down to figure out how much I need to cut off, which I decide on 2 inches. So the next straight piece I will mark out and cut at 22 inches, and then I will mark out and cut the 24-inch piece down to that length as well. And now with both pieces cut down to 22 inches, I will crimp the straight piece for the outflow side and slide both pieces onto the elbows I put together, and then measure to see if I have them around the same size. Then when I'm happy with how I have them, I will wrap more foil tape around where the straight pieces connect to the elbows and put the piece down into the drum to see how well it fits inside. And since I'm happy with the new size, I will mark another straight piece at 22 inches and 44 inches, then use my combination square to make my cut lines all around just before cutting them both again. Then I will remove the parts and add 2 bags to the other drum before moving them together to the area where I want to do all my testing at. Next I will cut the foil tape to length for the rest of the gutters I need to put together, and then tape up the elbows for the other drum. And now I will add the 22-inch straight gutter to the elbows. And here's where I figure out a better way to crimp the aluminum to make it easier to join the pieces together. What I do now is use needle nose pliers to clamp down on the outside corner of the aluminum and then twist both sides so it will bring the metal in enough to fit inside the other piece. I will go around and do this at all 4 corners, and it seems to work really well for joining the gutter together. So next I join all the gutter together and tape it all up using the foil tape I pre-cut for the rest of the roll I had. I will start by joining all the elbows and 22-inch straight pieces that will sit down inside the sand battery, and then add the elbows to the tops of the straight pipe. Then after taping the elbows to the tops of the straight pipes, I decide to try to join the 2 sections together, which will look like a big W, but I think I will skip joining the 2 in the future. The 2 joints break apart when I push them together to set them down inside the drums, which you will see next, so that's why this was probably a bad idea. In order to keep the drums fully side by side, I need to be able to push the outflow elbow further inside the inflow elbow, so I tear the tape apart so I can figure out how to do that. I decide to crimp the outflow elbow even more and then push them together as hard as I can, but I end up denting one of the elbows, so I have to pull it apart again to fix it. And to do that, first I will try using tools to push the dent back out, but since aluminum is a soft metal, it ended up being easier to just use my hand. Then after I have the elbows joined back together so the straight pipe is sitting as close to the drum walls as possible, I have to use regular duct tape to seal the gaps. I figure that will be safe to do since the gutters sticking out of the sand shouldn't see that much heat. So now that I have the gutters together up top and spaced out at the bottom in both drums, I can start adding sand after checking all the joints for tears in the high temperature foil tape. I already have 2 60-pound bags poured into each of the drums, so here I will be dumping in 6 more bags for a total of 8 bags in each drum at this point. Then I will stop dumping bags to see if I can still move the gutter around, which I can, so I will space the last straight pipe out so it's the same distance to the drum wall as the other 3 pairs are. And I will dump out 4 more bags for a total of 10 60-pound bags of sand in each drum. Then I will spread the sand around as best as I can so it's flatter inside. Next I will take a couple cheap water heating elements and push them down into the sand of each drum right before I start stripping the 14-gauge wire that is connected to my solar panel bus bars. And after I have the wires ready, I will loop the copper ends around so I can slide them under the screws on the top of the heating elements and tighten them up so they don't come loose. I immediately realize that I will get better results by putting 2 heating elements in each drum, so I run more wire and do that off camera, which you will see during my initial tests. So here are my solar controller readings before distributing power. And here is after I turn the switch on that will send some of my DC power coming in from the solar panels to my first sand battery. When I do the math, I'm sending around 560 watts down to the heating elements, and I have the switch wired up directly to the positive bus bar that the solar panels go to, which is before the charge controller. I have two 14-gauge wires hooked up to the switch that go down to each heating element, so I would imagine that I would get more power to them if I used thicker wire. So using the temperature sensor, I will stick it down into the sand of the drum that does not have the heating elements yet, and I will get around 61 degrees. And after about an hour of powering the elements, I will get around 73 degrees in the sand near the outside and around 200 degrees in between both heating elements. And I made the mistake of putting the plastic rings on the heating elements, which they just started melting, so I used my needle nose pliers to tear them both off. So at the end of the short day, I decide to turn the fan on and I only measure around 65 degrees for the air passing through the single drum with heat. And now I'm getting around 224 degrees in between the elements, close to 340 next to one element, and 260 next to the other with only 114 degrees near the gutters. So next I will add another two heating elements to the other sand battery and see what I can get with them both powered up by the solar panels. From here on out, I will use my thermal camera starting with the temperatures I get after the batteries have been sitting for weeks without any power. You can see the outside of the drum nearest to the drum with the AC electric heater inside is around 57 degrees outside and around 52 degrees for the sand and gutter inside. And again, this is with no power running to the elements for the weeks I was waiting for my thermal camera. So after switching the power on and immediately going downstairs, I can see a little heat coming from the elements and they measure just under 60 degrees. This is both of the heating elements running power in the sand of both drums now for under 5 minutes at this point, so as you can see there is hardly any heat built up yet. Now this is an hour later and you can see the heat start to spread through the sand with the heating elements in the first drum measuring at well over 220 degrees and the other heating elements with the shorter 14-gauge wires measuring closer to 300 degrees. Next I will go back and measure the outflow pipe and I'm getting around 57 degrees with the blower fan off so no air is coming out. Then when I go and turn the blower fan on, I will get a couple degrees less than with the fan off, so it's actually a little colder to blow air through the gutter. Now this is when it was at about 0 degrees outside and under 50 degrees in the house with just the one AC electric heater running in the basement. I'm saving up for more solar panels to dedicate to just these sand batteries because I use most of my solar power elsewhere, so I do plan to do more experimenting with this design. I'm hoping that I can heat more of the sand up, charging them up every day, but I won't know for sure until next winter when I have more panels going. So if you have any ideas or knowledge that can help make these more effective, please let us all know in the comments. Hopefully this video has helped and feel free to ask any questions that you still may have in the comments. Thank you for watching and please like and subscribe for more quick and on-point videos.